Okay, let's figure out the surface area of pyramids and cones. You guys have all seen pyramids before. They look like these right here. You can have any shape as the base of a pyramid you want. The ones that we're going to be calculating the surface area, though, are all going to be regular. In other words, they're going to be shapes where each angle inside is the same. The only reason the angles look different on this pyramid is because I tried to show it in 3D, so it's kind of at an angle. But basically, there's two things that we're going to need when we want to calculate the surface area of a pyramid. One of them is called a base edge. So that would just be like from here to here. That would be a base edge. The other thing I need is what's called a slant height. And a slant height is a line that goes from like the top of the pyramid and is a perpendicular bisector of a base edge. So this green one, that would be called a slant height. If I know those two things about a pyramid, I can calculate its surface area. And again, I can have a pyramid that looks like, or it can have any regular shape as its base. On this one, there's a pentagon for the base. That just means that this one's going to have 5 lateral faces instead of 4 like this pyramid did. So on this one of my base edges would be right here, but I would have a total of 5 base edges. And a slant height would look, I could draw one right here, or I could draw one right here. Doesn't really matter. A slant height is just a line that goes from the top of the pyramid and then is a perpendicular bisector of a base edge. So this would be slant height. Why do I need the slant height and a base edge? Well, here's why. If I want to calculate the surface area of one of these sides of the pyramid, it's just a triangle basically. And what I need to calculate the area of a triangle is its base, which would just be a base edge, and the height, which would be the slant height. So what I'm really doing here is if I wanted to calculate the area of one of the 4 sides of this pyramid, I would just take the base edge times the slant height, divide that by 2, and that would give me the area of this triangle. If I multiply that by 4, it would give me the surface area of all the lateral faces of the pyramid. Then what I would have to do is figure out the area of the base itself. If I added those things together, that would tell me the area of the pyramid. One thing to look out for, though, is instead of giving you the slant height, sometimes a problem will instead give you just the height. What that means is that's like if I dropped a line down from the top of the pyramid to the exact center of the base of the pyramid. So this right here would be the height. And I'll show you how to deal with that once we get into this first example that we're going to do. So it says I have a square pyramid. So I'm going to sketch that out real quick. I have a square pyramid with a base edge of 12. So base edge of 12. So each of these are 12. And a height of 16 centimeters. So notice it didn't say slant height, it just said height. So this right here, a line from the top of the pyramid to the middle of the base, is 16. So I have the base edge, which is good, but now I need the slant height. To figure that out, I'm going to have to use the Pythagorean theorem, and here's how. If I know that this side is 16, and the slant height would be right here, what I have is a triangle. So here's the slant height, here's the height, and then here's just basically half of a base edge. Right? This distance right here would just be half of 12, right? 12 would be all the way along one side. If I just want to get to the middle of the square, it'd just be half of that. So if I wanted to redraw this triangle, this would be 16, this would be half of 12, so 6, and this would be the slant height. Use the Pythagorean theorem to figure out what x is. I'm going to have 16 squared plus 6 squared. So x squared is going to be equal to 256 plus 36, which would be 292. And now I need the square root of both sides. let's call it 17.1. So the slant height of this pyramid is 17.1. The base edge is 12. Now, if I want to figure out the total surface area, there are sort of two things that I need to do, and so I'm going to try and cram those in here. The base is just a square, and so if I want to know the surface area of the base, I'm just going to take 12 and square it, which is 144. So that part's pretty easy. For the sides, I have 4 triangles that are all the same. 4 triangles with a base of 12 and a height of 17.1. So the area of the side, since I have 4 of them, I'm going to multiply by 4, and then it's going to be 4 times 12 times 17.1 divided by 2. All right, so this stuff in the big parentheses, that's just the area of one of those triangles, but then I'm going to multiply that by 4 eventually since I have 4 of those triangles. So 12 times 17.1 divided by 2. That's the area, 102.6, that's the area of one of the triangles. Now I'm going to multiply that by 4 to get the combined area of all 4 triangles. So the area is going to be that times 4, so 410.4. Okay, so I have a 144 and a 410.4. I'm going to add those together. That's going to tell me the area of the pyramid altogether. 554.4. Okay, this problem wants us to find the surface area of an equilateral triangular pyramid with a base edge of 6 feet and a slant height of 8 feet. Let's draw the pyramid first. If it's an equilateral triangular pyramid, that means that the base is an equilateral triangle. And so it would look something like this. And I could make these lines back here dashed or something to show that they're back behind this front side of the pyramid that I'm seeing. Okay, base edge is 6 feet. So that's 6, and this is 6. And a slant height of 8 feet. So if I draw a line from the top of the pyramid down to this base edge, that's going to be 8 feet. Alright, so I can pretty easily figure out what the 3 sides of the pyramid are in terms of their surface area, because they're each triangles, and triangles are just 1/2 base times height, or base times height divided by 2. So if I want to know the area of one of the sides of the pyramid, it's going to be the base, which is 6, times the slant height, which is 8, divided by 2. Right? Base times height divided by 2. That's just the formula for the area of a triangle. So the area of a side of the triangle is 48, right? 6 times 8 is 48 divided by 2, which is 24. So each of the 3 sides of that pyramid are 24 square feet. Okay, but I have 3 sides, so I'm going to multiply that by 2, because that's going to tell me what the area of all 3 sides put together is. And 24 times 3 is 72. So the sides of the pyramid add up to 72 square feet. Okay, now I need to know the base though, because then I'm going to add those 2 together, and that's going to tell me the area of the entire pyramid. So figuring out the base in this one's going to be a little bit more complicated than figuring out the sides was. I'm going to do that over here. All I know about the base right now is that it's an equilateral triangle and that each of its sides is 6. And so if I want to solve for the area here, I need a height. In other words, I need to know how long this line right here would be. So I'm going to call that x for right now. The one thing I know about equilateral triangles is that each angle is 60 degrees, right? Because that's going to be a 60. This has to be 60, and this has to be a 60. How do I know that? Well, I know that the three angles inside of a triangle have to add up to 180, and I know if it's equilateral that all three angles are the same. So the only way I can have three angles be exactly the same and add up to 180 is if they're all 60. So then what that tells me is if I just split this triangle into two, and I just look at this one on the right here, I would only have, instead of having 60 degrees up here, this part would just be 30 degrees, right? Because I basically split this 60 degree angle into two equal parts. So in other words, the triangle I have now, if I just look at the part on the right, there's a 30 degree angle here. That's the side that I would like to know. Then I have this base or this bottom side down here that I need to figure out basically. Well, if this whole bottom side is 6 and I cut it in half, that's going to be 3 and that's going to be 3. So here's the triangle that I'm actually working with right now. I have a 30 degree angle. The side opposite from that 30 degree angle is 3, and the one that I need to know to figure out its area, the x right here, is adjacent. When I have an opposite and an adjacent, I have a tangent. So the formula I'm going to use, tangent of my 30 degree angle is equal to the opposite over the adjacent. So then what I do next is I'm going to multiply by x on both sides. Those two cancel out. What that means is that on the right side all I have left is the 3. On the right side I have x times the tangent of 30. So let's figure out what that is real quick. Tangent of 30 is 0.577. So on the left side I have 0.577x. So I'm going to divide by 0.577 on both sides to figure out what x actually is. Once I figure that out, I can figure out what the area of this base actually is. So x is 3 divided by 0.577. Which is, we'll call that 5.2. So, if I want to know the area of the base, the area of the base of the pyramid here, base of my pyramid looks like this. Just to kind of backtrack a little bit. It's an equilateral triangle where all three sides are 6. The height, which is what I found up here with x, is 5.2. So if I want to know the area of the base, it's going to be the base of the triangle, which is 6, times the height of the triangle, which is 5.2, divided by 2. Right? Base times height divided by 2. So I'm just going to do that all in one step. I'm going to say 6 times 5.2 divided by 2, 15.6 is the area of the base. So now I just need to add that to what I already figured out for the sides. That'll tell me the area of the entire pyramid. And it's 87.6 square feet. All right, now let's do the surface area of a cone. Cones are pretty easy. I need two things. I need to know the radius of the base. So I need to know how far it is from the center of the base out to the edge of the base. Then I need to know the slant height, which I'm going to call L here. So the slant height is really any line that goes directly from the top of the cone down and is perpendicular with the edge of the base. Slant height, which I said I was going to call L. If I know those two things, I can figure out the surface area of a cone. Formula for it looks like this. So I do pi times the radius times the slant height. That's the area of sort of the cone part of the cone itself. This pi r squared, that's just for the base of the cone. So if I just want to know the cone part, I could leave this off. But if I want to know what the total surface area of the cone is, including the base, then I also add on a pi r squared. Make more sense once I do one. So I have a cone with a diameter of 12 inches and a slant height of 7 inches. So it's saying we have this cone right here where the diameter of the base, so be careful when it says that, The diameter of the base, in other words, all the way from one side of the base to the other side, is 12. Well, what does that make the radius? Well, if the diameter is 12, radius is half of the diameter, so the radius would be 6. And then it says the slant height, in other words, a line from the top of the cone down to the edge, is 7. So I have a radius of 6 and a slant height of 7. So let's just plug it into this formula right here. So the area of this cone is going to be pi times r times L, which it tells me here is 7, plus pi times the radius squared. Right? 6 squared is 36. So pi times 6 times 7 is what? Pi times 6 times 7 is 131.95. And pi times 36 is what? 113.1. So the surface area of this cone is just these two things added together. So the area of the cone is that number we just found plus 131.95. So the total surface area of a cone where its diameter is 12 inches and its slant height is 7 inches is about 245 square inches. Okay, this one, very similar. Another cone. Radius is 0.8 millimeters, and the slant height on this one is 2.2 millimeters. Okay. Area equals pi times the radius times the slant height plus pi times 0.8 squared. Actually, I should just write that out. 0.8 squared is going to be 0.64. If you don't believe me, I'll show you. Okay, now we just need to go through and figure out what this actually is. So first part, pi times 0.8 times 2.2. Let's just call it 5.5 plus pi times 0.64. Let's call it 2. So the surface area of this cone is just 5.5 plus 2, which would be about 7.5 square millimeters. Here's another cone. This time, though, instead of giving you the slant height, it's given us just the height of the cone. So remember, be careful there. Don't assume that we can jump right in and plug stuff into the formula when it gives you the height, because what we actually need is this one over here, the slant height. And then up here, it's telling us that the diameter, in other words, the distance all the way across the base, is 12. So we need to figure out the radius, and we also need to figure out the slant height. To figure out the radius, I'm just going to cut the diameter in half, and so if the diameter is 12, the radius is going to have to be 6. Figure out the slant height, I'm going to have to use the Pythagorean theorem. Right? I have a right triangle right here. This back side is 18. What is this one up here? Well, that's just going to be a radius, which I just figured out is 6. So I have a triangle where this side is 18, that side is 6, and the hypotenuse, that longest side across from the right angle, is the one that I want to know. So x squared equals 18 squared plus 6 squared. $324 plus 36 is going to be 360. So x squared is 360, and then I just need the square root of that. So 18.97. So the slant height, 18.97 centimeters. So the area of the cone is equal to pi times the radius times the slant height plus pi r squared. So pi times 6 times 18.97. $357.58. And then pi times 6 squared. 6 squared is 36. So I'm just going to do pi times 36. 113.1. I feel like I've been seeing that a lot lately. Okay, now I just need to add those two together. $470.68. And that's going to be centimeters squared, or square centimeters. Okay, so the total surface area of this cone is 470.68. And you'll notice I rounded differently to different decimal points in a couple of these problems. I shouldn't be doing that, but as I've always said, if you round accurately enough, one of the problems on the test, or one of the answers on each problem to the test, will be close to this. And so if you had an answer on the test that was like 470.42, you would know that would be the answer you'd want to pick for this question. Okay, last one, number 15. We're doing a pyramid. So we're back to pyramids. And so I have 5 total sides. I have 4 sides that are triangles, like this one in front, and then I have a base. So let's figure out what the base, the surface area of the base is really quick, because it's easy. The base edge of this pyramid is 8. And so since I know it's a square, all I have to do to figure out the base is just square that 8. 8 squared is 64. So I know that's part of my answer. So 64 is the base. Now I need to figure out what one of these triangles is. What you can see is that it gave us the height. Not the slant height, but just the height of the triangle is 10 feet. So there's another one where to find the slant height, which is what I actually need. I need this right here. I'm going to have to use the Pythagorean theorem. So this back here is 10. What is this part right here? Well, it's half of 8, right? If I went all the way from here to here, that would be 8 feet, but I just want to go to right here, so that's going to be a 4. So that's 4, that's 10. Here's my slant height. So x squared is going to equal 10 squared plus 4 squared. I know 10 squared is 100, 4 squared is 16. So x squared equals 116. I need the square root of both of those. 10.77 is my slant height. So now I can figure out one side. I'm going to shade it in. I'm going to figure out the surface area of this side, and then I'm going to multiply it by 4 to get all 4 lateral sides of my pyramid. So the surface area of this triangle here that I've shaded in red is just base times height divided by 2. The base down here is 8 feet. The height is this right here, this 10.77. So the side is base times height divided by 2. So 43.08. That's one of the sides of the pyramid, but I have 4 of them, so I need to multiply that by 4 to get the sides, the total surface area of all 4 sides. 172.32. Okay, so I have the base, and now I have surface area of the sides. The surface area of the entire pyramid is those two added together. So I'm going to do that plus the 64 that I did for the base. And it's 236.32. So the entire surface area of this particular pyramid is 236.32 square feet.